Okay, this is your physics NEET paper dated 8th July 2023. So, what is the first question? Solve now. In a Fraunhofer diffraction experiment, it is signals that using light of wavelength. Okay, the first minimum is formed at an angle 30 degree. Then the total number of maximum which can be observed on an infinitely large screen is okay. This is infinitely large screen. Okay, there is no limit for the screen, but or they were told first minimum is formed at an angle of 30 degree. And so first minimum forms at what angle? If you see here, it forms at an angle of lambda by a, right? Where we get actually a sin theta is equal to lambda, correct? For first minimum, right? So a sin theta, theta is 30 degree, sin 30 is 1 by 2 is equal to lambda. So we get a is equal to 2 lambda, correct? Then total number of maxima they are asking. So for maxima, what is the condition? A sin theta, which is path difference. A sin theta is path difference in diffraction experiment. We had done like this, if you remember, right? This like this and perpendicular. This was A, this was theta, A sin theta. So A sin theta for maxima should be equal to odd multiples of lambda by 2. So first central bright fringe, it comes anyway. But for first maxima, we take 2. It should be first minima comes at a and it is equal to lambda. First bright fringe comes at a and it is equal to 3 lambda by 2. So n equal to 1, it should be 3 lambda by 2. So 2n plus 1, that is n equal to 1, 2 plus 1 is 3, 3 lambda by 2, correct? So what will you get here? A is equal to 2 lambda, right? A is equal to 2 lambda we got. So we substitute 2 lambda sin theta is equal to 2n plus 1 by 2 into lambda. So lambda cancels. What do we get? Sin theta is equal to, you will get sin theta is equal to 2n plus 1 by 4. Right? Now they are asking total number of maxima. So if you see sin theta has a limit, it is always less than or equal to 1. So n, if you focus on n, 2n plus 1 is always less than or equal to 1. So plus 1 less than or equal to 4. The 1 goes here, 3. Then n is less than or equal to 3 by 2. That is 1.5. So n is less than or equal to 1.5. So on the screen, if you see, n equal to 0 is possible, and it anyway comes. N equal to 1 is possible. N equal to 2 is not possible because n is less than 1.5. Then n equal to minus 1 is possible. So 3 are possible, maximum, not more than that. So 3 is the answer. Then we get 92nd problem, we will see. The total angular width of central maxima in diffraction is, okay. And this is generic question only. So this is theta is equal to lambda by a for dark fringe. So first dark, and here first dark will come at theta is equal to lambda by a. So central bright fringe, central maxima's angular width is 2 theta, that is 2 lambda by a. That is option B. Then 93rd, an unpolarized beam of intensity I naught is incident on a pair of nickel prisms making an angle of 60 degree with each other. The intensity of light emerging from the pair is, okay. So a pair of nickels are there. So here unpolarized light is coming of I naught. So here it will be I naught by 2, correct, when it polarizes. And they are at 60 degrees. And whatever path axis it has, that path axis it will also have. And angle between this path axis and this path axis is 60 degree. So this will also make 60 degree with the path axis. So here Malu's law will come. I will be, whatever is coming, that is I naught by 2 is coming into cos square theta. Theta is 60 degree. Cos 60 is 1 by 2. Square is 1 by 4. 1 by 4 into I naught by 2 is I naught by 8. Option D. Then 94th problem we will do. So when the angle of incidence on the material is 60 degree, the reflected light is completely polarized. Okay, reflected light is completely polarized. Then this is Brewster's angle. Polarizing angle or Brewster's angle, this is correct. IB. And the velocity of the reflected ray inside the material is, okay. So this is IB. So tan IB is equal to mu we know, correct. So from IB is 60 degrees, tan 60 is root 3. So mu will be root 3. So now velocity of light in medium they're asking. Refractive index is c by v, velocity in the medium. Velocity of light in vacuum. So Vm is equal to c by mu. 3 into 10 power 8 is this. By root 3 is root 3 into 10 power 8. And 95th. A beam of light of wavelength 600 nanometer from a distant source falls on a single slit 1 mm wide. So this is lambda. And single slit, this is A. And resulting diffraction is observed on screen 2 meter. This is capital D. The distance between the first dark fringes on either side of the central bright fringe is, okay. This is a direct question. So in diffraction pattern, you see, this is lambda d by a, and from here also dark fringe will get lambda d by a. So distance will be 2 lambda d by a. This is your answer. Just substitute and get the answer. 2 into lambda is 6 into 10 power minus 7 by into capital D is 2 by, sorry, by A is 1 mm 10 power minus 3. So 24 into 10 power minus 4. So 10 power minus 4 meter. So mm is 2.4 mm. Option D. So then 96th problem we will go for 96th, right? So 96th will be a monochromatic. This is good problem. A monochromatic plane wave of speed c and wavelength lambda is diffracted at a small aperture like this. Okay, here diffraction is happening. The diagram illustrates successive wavefronts vibrating in same phase. So they are vibrating in same phase, and they are successive wavefronts. Means if this is of this is a wavefront which is a locus of all the crusts. Next will be again all the crusts, in phase means. So this will be lambda actually, and this will also be lambda. This will also be, this distance will be lambda, and in phase. After what time till some portion of the wave, sorry, after what time will some portion of the wavefront xy reach P? Okay. So how much time it will take? 1 lambda, 2 lambda, 3 lambda. So 3 lambda distance it has to cover. If some wave is there, it has to cover 3 lambda uh, wavelength. So it has to cover that much distance. So velocity is equal to distance, or speed is equal to distance by time. Speed is c, right? Wave of speed is c, given here. And how much distance it has to travel? 3 lambda by time, right? 1 lambda, 2 lambda, 3 lambda. So time taken is 3 lambda by c. Option C. Okay. Therefore, we will go for the next question. And the 7th, in an interference experiment, monochromatic light is replaced by white light. We will see. Okay, white light is there now. Interference pattern. So all yeah. You see, all white light means we'll have big wire, and all have different wavelength, correct? Right? All have different wavelength, where wavelength increases like this. And beta is equal to lambda d by d. We know this, right? So all will have a different fringe width. And x is equal to n lambda d by d, है ना? So all will have their maxima at different positions, right? So violet will have at the minimum, then it goes like this, and R will come here. So like this we'll get bright fringes, and X is positioned from the center of the screen, right? So we will get uniform illumination on the screen, no. Uniform darkness, no. There will be darkness, there will be illumination. Equally splashed white and dark bands. You will not have white bands because all are falling at different places. If all fall at one place only, Wigbar will mix and become white. So you'll get few colored bands with a central white bright fringe. Yeah. So you'll get central white bright fringe because at the center all will come and join, right? So Wigbar will join at center. So at the center it will mix and become white. So option D, 97. Then 98th problem. it is in a certain mistake there. In a certain double slit experimental arrangement, interference fringes of width 1 mm each are observed when light of wavelength 5000 angstrom is used. Keeping the setup unaltered, if the source is replaced by another wavelength, the fringe width. Okay. This is beta is equal to lambda d by d. So wavelength is altered. Then fringe width. What will happen to fringe width? Fringe width is 1 mm. So beta by 1 mm is equal to now it is 6000 angstrom, and now earlier it was 5000 angstrom. 6 by 5 into 1, that is 1.2 mm. So it is option C. 98 is C. Then 99 will go. Consider an interference pattern between two coherent sources. If I1 and I2 be intensities at points where the phase difference are pi by 3 and 2 pi by 3, then the intensity at the maximum is. Intensity at the maximum is 4 I naught only, that we know. Where intensity at phase difference pi by 3 is I1, they are telling. So I is equal to, we know, 4 I naught cos square 5 by 2 in interference. So phi they have given as pi by 3 phase difference. Pi by 3 by 2 is pi by 6. Pi by 6 is 30 degree. Cos 30 is root 3 by 2. Square is 3 by 4. So it is 3 by 4 of 4 I naught. Correct? You take 4 I naught as some k. Then what will you get? 4 I naught as k. Then you will get here 3k by 4. And this will be your I1. And I2 will be 4 I naught cos square. This is 2 pi by 3. Pi 2 is pi by 3. Pi by 3 is 60 degree. Cos 60 is 1 by 2. Then you will get 1 by 4 actually. You will get k by 4. And but you want so they are asking what is k is equal to, in terms of I1 and I2. So we have to do something to get k. So how to get? So, or if you do it like this also, this will be 3 I naught. I1 will be 3 I naught. And I2 will be, if you cancel this, it will be I naught. But we want 4 I naught. So 4 I naught is equal to I max. So we want this I max in terms of I1 and I2. So which option we can get? I2 is I naught minus 9 I naught. No, this will be negative. Minus 3 I naught minus 3 I naught is 0. You can substitute just 3 I1 is 9 I naught minus I naught is 8 I naught. 8 I naught by 2 is 4 I naught. Okay, this is the answer. Option C. And we have 100th column. Young's double slit experiment is made in a liquid. The 10th bright fringe in a liquid lies where 6th bright fringe lies in vacuum. The referendum. Okay. So 10 beta is equal to 6 beta dash. So 10 into this is lambda d by d. Setup is same only. D by d will cancel on both sides. So lambda will remain here and here. So here initially lambda in liquid is lambda by mu, right? Is into 6 into lambda in vacuum, right? Because mu is equal to C by V. V is equal to F lambda. So lambda in the medium, F into lambda in vacuum. F will be same always, whether even if you change the medium. So lambda in vacuum, that is just lambda by lambda medium. So lambda medium is lambda by mu. This will be lambda by mu and this will be lambda. So lambda cancels. Mu is equal to 10 by 6. That is 5 by 3, which is 1.67. Option C. Then we have 101. Two light sources are coherent when it is simple when their frequencies are equal. 101 is D. Frequencies are equal and their phase difference is constant. They are coherent. This is also okay, but this is more accurate or more correct. More features are true. Then 102 we will see. A hollow cylindrical beam of white light is incident on a converging lens in air. Okay, converging lens is there and a beam is incident. Axis of the beam coincides with principal axis of the lens. Okay, the cylindrical beam, hollow cylindrical beam. This is suppose lens. So beam is like this, hollow cylindrical beam. You can imagine like a hollow cylinder. The axis of the beam coincides with the axis of the principal axis of the lens. That is given. A screen is placed behind the lens. Okay, here. If FV is focal length for violet light, FR is focal length for red light. And if we see for a lens, na 1 by F is equal to, we have mu minus 1 into 1 by R1 minus all that is 1 by R1 minus 1 by R2. And R1, R2 will remain same even if you change the light. So here we know if lambda mu is inversely proportional to lambda. This is there. So if in VIBGYOR if you see lambda increases like this. So for red lambda is more maximum. So mu will be less. Mu is less, F is more. So for R, F will be more. So FR is greater than FV. So 1 and 2 is B. FR is greater than F. This is also there. Okay. Maybe some misprint, maybe equal sign, maybe there. Understood? So they will this white light na here red light will come. FR is more, so red light will come here. Then white light will be here somewhere. So there will be lights different places. So then 103, a hollow cylindrical beam of white light is same thing. Axis of beam coincides. Okay. The screen is behind the lens. Okay. If the distance between the screen lens is less than both FV and FR, obtained pattern on screen will be okay. It is less than FV also, so it will not converge. So we will have bands, but because all band at different extent, FR is more, hai. So FR is more means it doesn't bend much. FV is minimum, so it bends the most. So that will be the innermost circle. If you see like this circle, FV bends. Okay, sorry, like this. If you see the screen and light, now violet light bends the most, so it will come in the inner circle like this. And red will come somewhere here, it will bend least, so it will come in the circle but very high. So circular bands you will get because cylindrical is there. Circular bands you will get with uh, which will be the innermost, which bends the more, that is violet. Violet bends the most. Yeah, yeah. Focal length is less. It means it bends the most, so it will come inside. You can imagine, if something bend, it bends the most, so it will come inside. On which, if it doesn't bend only, then it will come. Just beam will come and it will form. Uh, if it doesn't bend only, it will form here circle, but it bends little bit, so it will form here. So innermost will be violet. So option B, 103 is option B. Then we have 104. Next double slit experiment. The distance between slits is D is equal to 0.25 centimeter and the distance of the screen D is equal to 120 centimeter from the slits. Okay. Wavelength, okay. I know it is center maximum. Then the minimum distance of the point from the center where intensity is I naught by 2 is K is equal to, okay. What is K? So intensity I naught by 2, right? And I naught is central maximum. So we have I is equal to 4 I naught cos square 5 by 2. But actually, if you see 4 I naught is given as I naught here, right? I naught is central maximus rate intensity. So now they are telling this is I naught by 2. So I naught cancels. We get 1 by 2. So cos square 5 by 2 is 1 by 2. That is 1 by root 2. Cos 5 by 2 is This is 45. So phi is equal to 90 degree. Phi by 2 is 45 degree. Phi is equal to 90 degree. So phase difference should be 90 degree. That is pi by 2. If phase difference is this much, then path difference is 2 pi is lambda. So pi is lambda by 2, lambda by 2, lambda by 4. It corresponds to lambda by 4 path difference, correct? Wherever 2 pi, 2 pi is proportional to lambda. So 2 pi is equivalent to lambda. So pi is equivalent to lambda by 2. Put pi is equal to lambda by 2. Lambda by 4 you will get. है ना? So path difference is lambda by 4. So where you will get path difference? Lambda by 4. So if you see path difference is equal to x d by d. है ना? Path difference is s d by d. S2p minus S1p. Path difference is x d by d. This should be equal to lambda by 4. So that is x, which is given as k. But we know minimum distance of the point from the center. Okay. So x is equal to lambda d by 4d. Correct? So x is equal to lambda d by 4d. Lambda is given, I think, 6000 angstrom, 6 into 10 power minus 7 into capital D is 120 centimeter. That is 120 into 10 power minus 2 by 4 into small d is 0.25 centimeter. That is 25 into 10 power minus 4. And 25 4 is 100. 10 power minus 2 I will keep here then. Right? 10 power minus 2, 10 power minus 2 cancel. Then what do you get? 12 6 is 72. 72 into 10 power minus 6 you will get. So minus 5 if you take 7.2 into 10 power minus 5 will get. So k into 10 power minus 5 they have told. So it is k 7.2. That is option A. 104 is option A. Then we'll go for next question. YDSC. Experiment. Okay. If the incident light consists of two wavelengths, lambda 1 split reflection is split separation is d, distance between. Okay. Maxima due to each wavelength will coincide a distance of. So where they will coincide? Where x is same. So x of bright fringes in first one is, suppose n1 of this will coincide with n2 of this, then it will be n1 lambda 1 d by d will be the position of first part, and this will be n2 lambda 2 d by d. So when this x and this x becomes n, it means they coincide. They are at same distance from the center. So where n1 lambda 1 d is equal to n2 lambda 2 d by d. That x we want, right? Where both of these are equal. So if you see, so if this happens, so x is multiple of lambda 1 by lambda 1 d by d also. It is multiple because n is an integer and a 2, 3 something like that. So 2 times of this or 3 times of this or 4 times of this. So it is multiple of x is a multiple of lambda 1 d by d, and x is multiple of lambda 2 d by t also. है ना? So they have asked where it will coincide. है ना? They have given LCM HCF. So if you see, it is least common multiple. So it is a multiple of lambda 1 by d, lambda 1 d by d also, and it is multiple of lambda 2 d by d also. So it is LCM. So it is option B. Sorry, it's B. Then we have 106. Figure shows wavefronts in still water moving in the direction of the arrow towards the interface PQ between shallow region and deep. Okay. Which of this is the figure? Okay. In deep denser region. Which of the lines shown may represent one of the wavefronts in deep region? Okay. So here if you see, the waves are coming. The waves are going. Arrow mark indicates what? The direction of arrow, moving in the direction of arrow. So wavefronts in still water moving in the direction of arrow. So wavefronts move in the direction of arrow. Okay. So in this direction, wavefronts are moving. So these are the wavefronts which are moving in this direction. Wavefront is moving in this direction. So how will be the wave moving? This is wavefront. Wave propagation will be perpendicular to wavefront. So waves are going like this. You can imagine water is going like this. So crust is will be moving like this. Crust or trough or any locus you take, wavefront will be moving in this direction. So wave is moving like this, right? And at this point of uh, interface, uh, point of incidence, this will be the normal. So it is shallow and deep. This is rarer. This is deep means denser. They have given question. Deep is denser. So rarer to denser towards the normal. So it will come towards the normal. It will bend like this. So the wave will bend like this, right? All the waves. So many waves are there here, and wavefront. So all the waves will bend like this actually. So if they bend like this, so waves will be going like this now. So wavefront is always perpendicular to the propagation of wave. So this is the normal to this surface, but this will be little bit like this, right? Normal means the normal to the wave propagation. So our wavefront will be this side. So this is the most suitable first option. They have asked wavefronts orientation, and so then we'll go ahead. 107, right? So what will be 107? Figure shows plane waves reflected from air to water, air to water, using Huygens principle and ABCDE lens on the diagram. Okay. The refractive index of air with respect to water is in the ratio. So if we see in this, this is incident ray. So this will be I like that. So this will be one of the ray. This will be one of the ray. So if you see, this is a wavefront, है ना? So from here to here, it takes some time. Suppose velocity in vacuum, so C into T. Some time it takes to come from here to here. And here its velocity will be velocity in the medium into T. In same time, it will also come from here to here, and it will come from here to here in same time. Because wavefront is there. This wavefront, this is wavefront. So this point, by the time it comes here, it comes from here to here, right? So now in this, if you see, uh, we know refractive index of water divided by refractive index of vacuum or air is velocity in air divided by, because mu is equal to c by lambda, c by v. So mu is inversely proportional to v. So v in air divided by v in water. So this is v in air and this is v in water. And so if you see v in, this is given as b. So v in air is b by t. So this will be b by t, and this will be uh, this is d. So d by this is d. So d by t. So t cancel. We will get b by uh, b by 107, right? Okay, b by d will get. But this is what they have asked, refractive index of air with respect to water. So they have asked refractive index of air with respect to water. Mu a by mu w they have asked. But we have got mu w by mu a. So your answer will be d by b, है ना? Not b by d. D by b is option D. 107 is option D. Okay. Then we'll go for next question. That is 108. So how much it will be? In Young's double slit experiment, the wavelength of red light is okay, and that of blue light is okay. And the value of n for which nth bright band due to red light coincides with n plus 1th bright band due to blue light. So this is bright band only. So n beta is equal to n plus 1 into beta dash. Both will coincide, so x will be same and x will be so this is 0 central, then this will be nth bright fringe. So first bright fringe comes at 2 beta actually, because after bright fringe dark fringe comes, then bright fringe comes. So 2 beta. So this will be at 2n beta, and this will be at 2n plus 2 of n plus 1 into beta dash. 2 will cancel, so this will remain. And beta is lambda d by d, so it is same setup. D by d will cancel, so only n lambda 1 is equal to n plus 1 into lambda 2 will remain. And so n into red lights, red light is 78, 800 is there, and that 0 will cancel. 52, 0 will cancel. So here 13 4s are, no, 26 2s are, 26 3s are, and 3n is equal to 2n plus 2. So n is equal to 2. So answer is second option. 188 is B. 188 is B. Okay. Then we have 109 in Young's double slit experiment. If the slits are of unequal width, what will happen? Right? So slit, if they are of unequal length, then fringes will not be formed. No, fringes will be formed. Then position of minimum intensity will not be completely dark. Yeah, because unequal width means, I had told you in class, I think, that I is proportional to A square, and intensity is also proportional to width. If width is more, intensity will be more. So width is proportional to A square. So amplitude is depending. So if width is of unequal, if we have unequal width, then unequal amplitude will be there. So minimum intensity will be A1 minus A2 whole square. Hai na? It will be proportional to this, which is not 0. So it will not be completely dark. Some intensity will be there. This is the correct option. Bright fringes will not be formed at the center of the screen. No, bright fringe will be formed. Then because the path difference is 0, the construct will interfere, but intensity will be not 4 I naught square, but A1 plus A2 whole squares proportional to A1 plus A2 whole square. And distance between two consecutive bright fringes will not be equal to the distance between two consecutive dark fringes. No, it will be equal. Beta will be, so this is wrong. Beta will have some value. N lambda d by d, okay. Then 110 will come. A two slit Young's interference experiment is done with monochromatic light of wavelength. Okay, these slits are 2 mm apart. The fringes are observed on a screen placed 1 centimeter away from the slit. Slit experiment, okay. Wavelength is given, since lambda is given, and lambda is given. Slits are 2 mm apart, small d. Fringes are observed on a screen 10 cm away from the slits, capital D. Transparent plate of okay plate is there, is placed at the interference when shift by 5 mm. Okay, shift. Referenders are transparent. So shift is equal to 1 minus mu minus 1 into T into capital D by D. This is shift, and this shift is given as 5 mm. 5 into 5 mm. Okay. And thickness of plate is 0.5 mm. So mu minus 1 into this 0.5 mm. So 0.5 m. This m and this mm will go into capital D is given as 10 centimeter, 10 into 10 power minus 2, divided by small d is given as 2 mm, 2 into 10 power minus 3 is equal to 5. So this will be 1 the 5 the, this 5 will cancel. So this will go up, 10 power minus 3 will become plus 3, plus 3 minus 2 is 1. So it will become 10, then this will become 5, 0.5 into 10. So 5 I will take that side. Mu minus 1 is equal to 1 by 5, that is 0.2. So mu will be equal to 1.2. This is option A. Right, 110 is A. Then we'll go for the next question, 111. In Fraunhofer, diffraction for single slit central eczema is bright on the both side of it. Maybe occurs symmetrically. For diffraction maxima, A sin theta is equal to 2n plus 1 into lambda by 2. This is a normal case only. For diffraction minima, yeah, this is also normal case only. Light of wavelength lambda passes through a slit of width W. Okay. And forms diffraction pattern on viewing screen. If this light is then replaced by light of wavelength 2 lambda, the original diffraction pattern is reproduced if the width of the slit is changed to. So this is the slit width. Huh? So W is the slit width. A is equal to W basically. Huh? So now they are telling it is replaced by 2 lambda. Original diffraction pattern is exactly reproduced if width is changed to. So A sin theta, and here we have lambda we have. So for it to reproduce it again, this theta should not change. है ना? So now lambda has become 2 lambda. If theta should not change, this 2 should be taken care. है ना? So if A was earlier W, now we can make it 2W, so that this 2 and this 2 will cancel. Theta will remain same. And here also same, 2 lambda, 2W. 2 will cancel, it will remain same only theta. So all the fringes will again come at same thetas, same positions. So the pattern will not vary. Yeah. So it is 2 lambda. So it is 2 lambda. So 1 is 2 lambda. Then we have 112. So two beams of light having intensities I and 4i interfere to produce a fringe pattern on screen. Phase difference between the beams is pi by 2 at point A, pi at point B. Then difference is between resultant intensities at A and B is okay. So intensity is okay. These are two different intensities. So I resultant is because amplitude is like a phasor vectorially we add it a1 square plus a2 square plus 2 a1 a2 cos theta, where theta is phase difference. So this will become a square. So I is proportional to a square. So this is the resultant intensity is equal to I1 plus I2 plus 2 root I1 root I2 cos theta. This is the formula. Theta they have given, I1 and I2 they have given. So first one is pi by 2, cos pi by 2 is 0, so it will be just I1 plus I2, that is phi I. And later it is pi. Cos pi is minus 1, so it will become I plus 4i, phi I minus 2 into I root I into root 4i, that is root 4i is 2 root I, 2 to the 4, root I into root I is I, and this is minus cos pi minus I took, so this will be I. So so at A it will be this much, at B it will be I. What is the difference? 4i. 112 is B. Then we have 113. In next double slit experiment, we get 60 fringes in the field of view of monochromatic light of wavelength 4000 angstrom. If we use monochromatic light of wavelength 6000 angstrom, then number of fringes obtained in the same field of view. Okay. So means basically that many fringes should fit. So beta is fringe width. So earlier it was 60 betas. Now how many betas will come? They are asking. है ना? Suppose n beta. Then 60 beta is equal to, so beta will change now when I change lambda. So 60 beta is equal to n beta dash. So 60 into beta is lambda d by d is not changing. So lambda is only there. So earlier lambda was, when 60 it was 4000 angstrom. Now we are using 6000 angstrom. So 0 cancel. N will become 60 into 4 by 6. 10, 40. 113 is C. Then next question. What is the next question? One of the double slit experiment is covered by thin glass plate of refractive index 1.4 and other by thin glass plate of refractive index 1.7. The point on the screen where the central maximum fall before the glass plate was inserted. Okay, the point on the screen where center maxima fall before the glad plate was inserted. So before it was inserted, where the central maximum used to come is now occupied by what had been the fifth bright fringe. है ना? This fifth bright fringe has come there. It means shift is 5 beta. Not 5 beta, just 10 beta. है ना? Because we have dark fringes also in between. So this will be central fringe. Then first dark will come, first bright will come. So first bright, if it replaces, then this beta and this beta, 2 beta will come. Like that, fifth bright fringe, 10 betas are shifted. So shift in this is 10 beta. है ना? Assume the plate have the same thickness T. Okay, both the plates and wavelength is this much. Value of T is. So we know shift is equal to mu minus 1. Okay, these here are how many plates? Okay, 2 plates are there. One in front of one and other in front of other. So if you see, this will make it shift upward. It will make it shift downward. This this downward split will make it come down. This will make it go up. So shift will be how much it shifts minus how much it shifts. And so this refractive index is more. So shift is mu minus 1 into T by d by d. This is shift. So basically, whoever has mu more, that will shift more. So this will shift more. So down shift will be more than upward shift. That's why fifth is coming down. And otherwise, somewhere from here it would come up. And this is okay. Shift due to one plate. 2 plates are there, so shift will be the same thickness. So if this is mu1 and mu2 is there, mu2 minus 1 into T d by d. So shift will be subtraction of both. So T d by d I will take common. This will become mu2 minus 1 minus mu1 minus 1 minus plus 1 minus 1 minus plus 1 cancels. We'll get mu2 minus mu1. So this will be the shift, and this shift is 10 beta. So mu1 minus mu2 is 1.7 minus 1.4, that is 0.3 into thickness. We have to find okay, and capital D is given as capital D is given, okay, no, this is fringe width, so lambda d by d. So d by d cancels. We get 10 lambda here. So 10 into lambda is uh, uh, lambda is 480. So 480 nanometer into 10 power minus 7. So what will you get? This is 0.3, that is 3 by 10. So 3 ones are 3, 1 za 6 za 0 ja. So 160, and this 0 will go here. 10, 20, 30. So 16 into 10 power 3. And we have 10 power minus 9 here. So 10 power minus 6. So 16 micrometer. 16 micrometer. 114 is C. Okay, it's 8. Okay. Fifth bright fringe. Okay. If you take 5 here, you get 8 actually. But okay, wait.